Here we are at example 1 from our 5.2, number 27 notes. We're looking at something called synthetic substitution. Now, before we actually kind of get into how to do synthetic substitution, I figured we would try one using just direct substitution. So in other words, we have this g of x function, here he is, and we're pretty much just taking -2 and throwing him in for x, anywhere that there's an x inside of this guy. So when we do that, we end up then with g of -2, in other words, throwing -2 in for x into the function. We end up then with -4 times -2 being cubed plus 3 times -2 squared plus -2 minus 1. Again, this is just direct substitution, throwing -2 in there and seeing what it comes out to be. So we end up then with -4, and then -2 raised to the third power is -2 times -2 times -2. So we're going to get a negative, and then 2 cubed gives you 8. We'd end up with -8 there. Plus 3 times -2 squared gives us +4. Plus -2 minus 1. So simplifying this even further, we end up with -4 times -8 gives us +32. And then 3 times 4 gives us 12. So then -2 minus 1. And now just adding these, we end up with, looks like 44 minus 2 minus 1. So 44 minus 2 is 42, minus 1 gives us 41. So when we use direct substitution, g of -2 came out to be 41. Now for synthetic substitution, how this actually works is we're going to go ahead and take that -2 and throw him inside of like a little box over here. Next, what we do is we're going to go ahead and take our coefficients from our polynomial. Notice how it goes x cubed, x squared, x, and then just the constant. If you were missing a term, you might have to maybe think around how to get there, like how to actually get that coefficient. I think example 2 illustrates that pretty nicely, so we'll see that when we get there. But for right now, we just take the coefficients -4, 3, in this case 1, and -1. We're going to write that right over here. -4, 3, 1, and -1. Next, what we're going to do is leave ourselves some space and then just draw a bar. Now, for the first guy, he always drops down every single time. This first guy is always just going to drop down. You'll always see that for synthetic substitution. Now we're going to go ahead and use our guy that's in the box. So anything below this bar, we're going to multiply this number in the box with. So -2 times -4 gives us +8. And we're going to place that +8 right here under the next item. In this case, right under that next 3. Then after we've multiplied, put that number right here, we always add going down. So 3 plus 8 gives us 11. Every single time, you just always add going down. Then you pretty much just repeat the exact same process. So -2, taking that number inside the box, times the number underneath the bar. In this case, -2 times +11 gives us -22. Then we just add going down, so -21. Multiplying -2, again with that number underneath the bar, -21, gives us +41. I'm sorry, +42. And then we just add going down. So -1 plus 42 gives us 41. And this last number over here, when we're talking about our synthetic substitution, is really what we care about. Notice it actually matches what we got when we use direct substitution. So for g of -2, using synthetic substitution, it also comes out to be +41. Now, if this synthetic substitution seemed a little confusing at first, don't worry. We're going to see many, many examples, and in fact, from my experience, most people actually really prefer using synthetic substitution, because once they kind of get the pattern down, it's usually kind of like easy points for them. And in fact, we'll talk about how it's even more applicable in future sections to come. So synthetic substitution, also known as synthetic division, does not quite go away. We see it again, but from my experience, most people actually really like it because it kind of just follows that same template. Again, though, that is example 1 from our 5.2 number 2 set of notes.